Recent research indicates that rats possess the ability to imagine. Our cognitive existence as humans is characterized by the constant activity of our mind. This encompasses a range of activities from deciding on what meal to prepare for dinner to reminiscing about our previous seaside holiday. New research conducted by the Genelia Research Campus of HHMI has discovered that animals possess the ability to imagine. The Lee and Harris labs collaborated to create an innovative system that merges virtual reality with a brain-machine interface. The system is designed to explore the inner thoughts of rats in a unique way. The discovery was made that animals, much like humans, possess the ability to contemplate locations and items that are not currently within their immediate view. This cognitive function allows them to envision walking to a particular destination or manipulating a remote object to reach a specific point. Similar to humans, rodents also exhibit specific neural activity patterns in the hippocampus when they encounter places and events. The hippocampus is responsible for spatial memory in the brain. According to a recent study, rats have the ability to deliberately generate these neural activity patterns to recollect distant locations that are far from their present position. According to Chongxi Lai, a postdoctoral researcher from the Harris and Lee labs and the primary author of a paper that details the latest findings, rats have the ability to mentally conjure up a representation of a place in the surrounding environment without actually having to physically go there. This means that even if the rat's body is not moving, its spatial awareness and imagination can transport it to a location that may be far away. The capacity to conceive of places that are not presently within one's immediate vicinity is a fundamental aspect of both reminiscing about past events and envisioning potential future scenarios. As per the authors of the study, this implies that animals, much like humans, possess a type of imaginative capability. According to Albert Lee, a former group leader at Genelia who is now an HHMI investigator at Beth Israel Deaconess Medical Center, one of the most extraordinary abilities that humans possess is the power to imagine. However, recent explorations have shown that animals also possess this faculty, and we have now discovered a method to examine it more closely. The commencement of the project took place 9 years prior, when Lai arrived as a postgraduate student at Genelia. He had a notion to investigate whether or not an animal could engage in cognitive processes. It was then that his advisor, Tim Harris, a senior fellow at Genelia, recommended that Lai speak with Lee, whose laboratory was similarly interested in this line of inquiry. Consequently, Lai walked down the hall to have a conversation with Lee. In a joint effort, the laboratories collaborated to create a mechanism that would allow for the comprehension of animal thought processes. Their goal was to construct a thought detector that could instantaneously gauge neural activity and interpret its significance. The direct link between brain activity and an external device is established through a brain-machine interface, BMI, within the system. The team's system is designed to connect the electrical activity in the rat's hippocampus with its location within a 360-degree virtual reality arena. The mental maps of the world that are used to recall past experiences and imagine future events are stored in the hippocampus. The generation of specific hippocampal activity patterns associated with places and events is necessary for memory recall. It was previously unknown whether animals had the ability to control this activity voluntarily. By using BMI, researchers are able to examine if a rat can stimulate hippocampal activity by simply thinking about a location in the arena without physically moving to it. This helps to determine if the rat is capable of creating an imaginary representation of the location. After developing the system, the researchers were required to create a thought dictionary to decode the rat's brain signals. The dictionary compiles activity patterns that are evident when the rat experiences something, such as places in the virtual reality arena. Shinsuke Tanaka, a postdoctoral researcher in the Lee lab, has designed a VR system that uses a harness to secure a rat. The rat walks on a spherical treadmill, and its motions are projected onto a 360-degree screen. The rat is incentivized with rewards for successfully navigating to its objective. Simultaneously, The BMI system documents the hippocampal activity of the rat. By analyzing which neurons are stimulated as the rat moves through the designated area to achieve each objective, the researchers have the ability to pinpoint the responsible signals. These signals then become the foundation for a real-time hippocampal BMI, which translates the activity of the brain's hippocampus into actions displayed on the screen. The following course of action taken by the researchers involves the disconnection of the treadmill and the provision of a reward to the rat for performing the hippocampal activity pattern related to a particular end goal. This task, which is referred to as the jumper task, shares its name with a 2008 film. The BMI decodes the brain activity of the animal to enable movement on the screen of the virtual reality space. The animal is able to navigate towards the reward using its thought process, much like humans do. For instance, when we are requested to buy groceries at a familiar store, we often imagine the different locations we will pass through before leaving our house. In the second challenge, referred to as the Jedi Challenge in tribute to Star Wars, the rat accomplishes the task of transferring an object to a specific location using only its thoughts. Although the rat is immobile in a simulated space, it moves the object to the desired destination by manipulating its hippocampal activity in the same manner as an individual who imagines walking to the coffee machine in their office to fill a cup with coffee. The scientists subsequently shifted the goal's placement, compelling the rat to generate new activity patterns connected to the new location. Through their research, the team discovered that rats possess the ability to effectively regulate their hippocampal activity comparable to that of humans. Additionally, the rats exhibit the capacity to maintain this activity for extended periods, retaining their focus on a specific location for a duration of several seconds, similar to how humans revisit memories and conceptualize hypothetical situations. Harris remarks that it is astonishing how rats acquire a cognitive association with one specific location for an extended duration, despite our possibly simplistic views regarding their attention span. According to the authors, the research indicates that BMI can effectively explore the activity of the hippocampus, thus creating an innovative method for investigating this vital area of the brain. In addition, since BMI is progressively utilized in prosthetics, this fresh study also offers new potential for creating inventive prosthetic devices that follow the same principles. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.